Okay, hello everybody. So today I'll be teaching you what are logic gates. They're nothing but it is an integrated circuit which can be divided into mainly three categories. The first one being basic gates, universal gates, and derived gates. Basic gates is further divided into three parts, universal in two and derived in two. So basic gates may be categorized as NOT, and OR. Universal gates as NAND and NOR. Derived gates as XOR and XNOR. Now, let's dive into the detailed part of basic gates. Now, basic gates are of NOT and an OR. Now, NOT can be represented by a dash at the top or a line like this. AND gate may be presented by a V, inverted V, or a dot. OR gate may be represented by a plus sign or a V. Now, how do you draw these gates? In NOT gate, you have a single input, triangle, circle, single output. So if you enter A, you get A negation. AND gate, two inputs, draw a D, and that is your AND gate. OR gate, two inputs, then a little curvature and a triangle, and that's your OR gate. Now, what if we have something as A, B, A plus B, and A negation? AB is nothing but can be written as A into B. So first thing you're going to do is draw A, draw B, take out two lines from it. Alright. Next thing you're going to do is take out a line from A, take out a line from B. AB is nothing but A and B, so put the AND gate to this. A plus B is nothing but OR, so put the OR gate to it. A negation is nothing but the NOT gate. So A triangle this. Now, what if there was a plus sign between all of them? What would you do is you have individually solved these. Now, in the end, just bring them together and put an OR gate. And that's how you solve this. So these are your basic gates, NOT, AND, and OR. Now let's come to your universal gates, which are NAND and NOR. Now the name itself suggests NAND can be broken into N and AND. N is nothing but negation of the AND gate is said as NAND, and negation of the OR gate is called as NOR. Now why are they called as universal gates? They're called as universal gates because they can be used to fully realize other gates. By this what I mean is that from NAND gate you can make all other gates such as NOT, AND, OR, XOR, XNOR. And from NOR gates, similarly, you can make all other gates. That's why they're called as universal gates. However, from an OR gate, you cannot make an you cannot make an AND, or you cannot make an AND from an OR gate. However, from these, you can. So let's see how these are represented. NAND gates are represented with a D and a negation sign on top. Two inputs, one output. Two inputs, one output. That's your NOR gate. With a OR gate and a negation on top is your NOR gate. Now let's see how to make different gates or the basic gates from your universal gate. So first let's try and make NOT using NAND and NOR. How will you make this? You have basic input A, put your NAND gate, and here you'll get A negation. You have basic gate A, put your NOR gate, you'll get A negation here. Now let's talk about the AND gate. Now we know AND is nothing but A into B. So let's make our two input values AB. Now what I'm going to do is put an AND gate, NAND gate to it, and another NAND gate. Why did I do this? Now let's have a look here. If you have A is equal to 1 and you negate A, you'll get 0, and then you further negate the negated A, you'll get 1. So you'll get what you started with. It is equal. So here what happens is you have A into B negation here, and what will happen here? You'll have A into B negation, whole negation, which will end up giving you AB. So that's why you just apply two NAND gates. Now and using NOR. You have A, you have B. So you're going to apply your NOR gates and you're going to get a bigger NOR gate. That is your A, B using NOR gates. What happened here? Same, it got negated, and when it further got negated, it will give you A into B. What you have here is nothing but A negation, B negation, whole negation. So it will give you A, B. That's why you first negated them and then you put the main NOR gate. No, yes. Now let's make OR using NAND and NOR. So you have again two inputs for OR. I'm applying my NAND gate, I'm applying my NAND gate, and I'm further applying my NAND gate. What happens here is you get A negation, B negation, you get nothing but A negation into B negation, which when expanded and negated, you will get A plus B. So gives you your OR. Now OR using NOR gate. Nothing but A and B inputs you have. Draw the line, draw your OR gate, and draw another OR gate, and there you have A plus B. Now let me just explain this to you in further detail. Now if you have A is equal to 1 and you have A negation, you will get 0. Similarly for B, if you have a plus sign and you negate it, you will get an AND sign. If you had an AND sign and you negate it, you will get a plus sign. So that's why you're negating all of these change from A and B to A plus B. Similarly, it happens here. That's why this is how we draw them. Now let's talk about the derived gates. Now derived gates are XOR or XNOR. What this is, it is nothing but A negation B plus A B negation. And the entire negation of the XOR gate, as you can see, XNOR, that is negation of the XOR gate, is nothing but A negation B plus AB negation, whole negation. How do you draw these gates? So as they are OR, they'll be drawn like this. So this is your XOR gate and your XNOR gate is nothing but with a negation on top. Now let's talk about another very important rule, something called as sum of product and product of sum. Alright, sum of product and product of sum. What is this? Sum of product is nothing but you have AB plus BC plus CD. This can be called as sum of product. Why? Because there is the sum of the product of AB, BC and CD. Now, whenever you have sum of product, you use the NAND gate. You use the NAND gate. And whenever you have product of sum, now what is product of sum? If you have A plus B plus C into C plus D plus A, what is happening here? You have the product of the sum of A, B and C. Product of the sum of C plus D plus A. During this, you put the NOR gate or you apply the NOR gate. Now, using these two formulae or these 2 points, you can easily draw XOR and NEXOR and XNOR using NAND and NOR gates. Here you can see this is the sum of product. So you can use NAND gates to make these gates. In this way, from NAND and NOR, you can make all gates. So here's a little summary. Hope you liked it. Please do share, comment. I'll be happy to take all doubts.